A force of 8 pounds compresses a 14-inch spring a total of 5 inches. How much work is done in compressing the spring from a length of 12 inches to a length of 10 inches? This one is a little bit trickier. Let's go ahead and work it out. First, we're being told that a force of 8 pounds compresses a 14-inch spring a total of 5 inches. We don't have to, but let's go ahead and draw a picture so that you see what's going on. So here's 0, and it's a 14-inch spring, so here's 14. And maybe this here is our fancy spring. So in this case, the force acting on the spring is equal to 0. All right, then we're told a force of 8 pounds acts on the spring, so the force here is going to be 8, and it compresses at a total of 5 inches. So here we have 0, here we have 5, and then maybe here's 14. And so that's what happened there. Okay, now we're going to use Hooke's law to find the force function. Notice we haven't even read the rest of the question yet. No matter what, usually you have to find the force function first. So Hooke's law says that the force acting on the spring is directly proportional, so K, times the distance that the spring is stretched or compressed. So directly proportional to the distance, so Kx. We're told that the force is 8 pounds. So F is 8, and we have K, and it's compressed 5 inches, so this is 5. So K is going to be equal to 8 over 5. And so now we've successfully found our force function. So f of x is kx, so 8 over 5 times x. Okay, now the tricky part. We want to know how much work is done in compressing the spring from a length of 12 to a length of 10. So let's go ahead and draw our pictures again. So here's 0, and then here's 14. And we're going from a length of 12. So if we're going to stay in line with the pictures we've been drawing, our picture is going to look something like this, where this distance here is 12 inches. Now, if this distance here is 12 inches, this must be 2. And we want the work done, so we need the work required to take this spring, so we still have the 0 and the 14, and compress it to a length of 10 inches. So we want this distance here to be 10 inches. Well, that's going to happen, well, let's see, this is 14, this is 0, so this must be 4. In other words, we want the work required to compress the string an additional, well, rather from 2 inches to 4 inches. So it's kind of tricky because of the wording. It says length of 12, which is this picture, to length of 10, which is this picture. Okay, let's go ahead and finish. So we want the work, which is the integral, and we're going to go from 2 to 4. So 2 to 4, and then we have our force function, 8/5 x dx. So this is equal to 8/5 x squared over 2, which is 8 over 10 x squared. Whoops, forgot to put this here. So 2, 4, 2, 4. And first you plug in the 4, so we end up with 8/10, 4 squared, and then you plug in the 2, so minus 2 squared. And you put this in your calculator and you work it out, and you get about 9.6 inch-pounds. So I kind of rushed that at the end, but hopefully this part here made sense. So again, you have a length of 12 inches, and you're going to a length of 10. So if you draw a picture and show what 12 inches looks like, and then you show what 10 inches looks like, you can see that you're really just going from 2 to 4. I hope this helps.